Today we're going to be working on the distributive property. You can see it here in the definition that when you use the distributive property, you distribute a number or variable that is outside the parentheses to what is inside the parentheses. So to begin with, you're going to be rewriting a problem. Here's some examples algebraically, and then we'll talk about the one that is numerical on the right-hand side in just a minute. So for example, A times B plus C can be rewritten as A times B plus A times C. You can see that both expressions would equal one another because there's an equal sign. We can reverse this and put the B plus C, which is in parentheses, first times A, but we're still going to distribute that A to the B and the C on the inside and rewrite it as B times A plus C times A. In the examples in the purple and green, you can see you can also apply this to subtraction problems. The one on the right, you can see in numerical form, is written as 4 times 6 plus 3. So when we distribute, another word for this is when we pass out that 4 to what's inside parentheses, we can rewrite it as 4 times 6 plus 4 times 3. You can see in both examples that we're going to get the same answer. So in the one on the left, 6 plus 3 is going to give you 9. And we have 4 times that 9, which 4 times 9 is going to equal 36. On the right-hand side, once we've distributed the 4 to the 6, we get 24. And 4 times 3 is 12. We add 24 plus 12 together, we get 36. You can see no matter which way we do this, we're going to get the same answer. But when we get into algebraic problems like this, when we have letters involved with numbers, the distributive property is going to be very, very important. Now, we can also use the distributive property to make our problems easier. For example, 4 times 105, I can multiply as 4 times 100 plus 4 times 5 to get us our answer of 420 very easily. Stop the video and you try the other 3. If I was doing these problems, I'd take 3 times 90 plus 3 times 7, which is going to give me a final answer, which I hope you got, is 291. Don't get nervous when we have decimals. We can take the 5 times 2, which gives us 10, and also add the 5 times, now remember this is a decimal, so this is 0.9, so that would give us 0.45, or 4.5. Okay, so 5 times 2 is 10, 5 times 0.9 is 4.5, so when you add those together, you're going to get 14 and 5/10. We do 8 times 7. Plus 8 times 0.02. 8 times 7 is 56. And 8 times 200ths is 1600ths. So when we add those two together, we're going to get 56 and 1600ths. So using our distributive property and just regular problems can be helpful in solving them quicker and easier. Now, let's apply the distributive property to a problem that has numbers and letters in it. So we need to distribute this 3 to both the x and the 7. So we have to multiply them. 3 times x is going to give you 3x. 3 times 7 is a positive 21. So we get 3x plus 21, and that is our simplified answer. We can't put the 3x and the 21 together because they are not like terms. Now let's apply it to these four problems. 8 to the x, cancel it out, and 8 to the 2. 8 times x is 8x. 8 times 2 is 16. Now this next problem gets a little tricky because we have negatives involved. So we need to distribute this 7 and minus t to this negative 4. So negative 4 times 7, or you can say it as 7 times negative 4, is going to give us a negative 28. And once again, I distributed it to this 7 in the inside. Now we have to distribute this negative 4 to this negative t. And negative 4 times negative t, and negative times negative, we remember, is a positive 4t. So we can rewrite that as negative 28 plus 4t. Now let's distribute the 9 to the 3m. 9 times 3m is 27m. 9 times 5 is 45. Let's distribute this negative 2. Negative 2 times 6y is negative 12y. And negative 2 times negative 4 is a positive 8. Guys, try this one on your own. Negative 8 times 4z is negative 32z. And then negative 8 times a positive 6 is going to give us a negative 48. So I'm just going to write minus 48. That way I don't have a plus and a negative together. Never want to put two signs together. It just makes it a little bit confusing. So answer is much better read, negative 32z minus 48. And we can apply this also to formulas. And so we must understand the area of a triangle is A equals 1/2 the base times the height. So for example, if we are given a triangle here, and we write a height of 8 minus 3y in here, and we apply the base and give the base a length of 12. So we can insert these into our equation to find our area. So area equals 1/2. Now the base is 12, so we're going to replace b with 12. And then we're going to replace the height with 8 minus 3y, which we have been given here. So now we need to distribute. If it's me doing this problem, I know I can take half of 12. 1/2 times 12, that gives me 6. So I'm going to rewrite this as 6 times 8 minus 3y. So once again, I multiplied 1/2 times 12 to give me 6. Now I have to distribute. So I distribute the 6 times the 8, which gives me 48. 6 times negative 3y, which is negative 18y. So our final answer here is the area is equal to 48 minus 18y. If someone would tell us what y is, we could solve it. Or if someone told us our area, we could solve it. The equation for y. We can also apply this to the area of rectangles. And we know the area of a rectangle is the base times the height, or some people like to also call this the length and width. Neither one is fine. You're going to hear it both ways. So we just know we need to multiply the length times the width or the base times the height, whichever way you look at that. So if I was multiplying, okay, and I gave us a base or a length of 2x plus 5, and I gave us a width or a height of 7, we could set up an equation to multiply these together. So A equals a base of 2x plus 5 times the height or width of 7. So once again, we're going to distribute. So area is 7 times 2x, which is 14x, and 7 times 5, which is 35. So hopefully now you understand how to use your distributive property to multiply everything that's outside the parenthesis by what is inside the parenthesis.